children. I hope all of you are well. Are you completed 1.3? Then we will continue this real numbers. Next topic is irrational numbers. What are irrational numbers? The numbers which cannot be expressed in the form of P by Q are called irrational numbers. The numbers which cannot be expressed in the form of P by Q are called irrational numbers. What is rational numbers? The numbers which can be expressed in the form of P by Q. P and Q are integers and Q not equal to 0 are called irrational numbers. Just opposite coming for irrational number. It cannot be expressed in the form of P by Q. Then and it is denoted by the letter S. S is equal to the set of irrational numbers. Example for irrational numbers, root 2. The square root of all prime numbers are irrational numbers. That is root 2, root 3, root 5, root 15, etc. root 17, etc. are irrational numbers. And the numbers, or we can write in the non-terminating and non-recurring numbers also irrational number. Here see, this is a non-recurring, non-terminating decimal. Non-terminating, it is not stopping, the division is going on. And the numbers which are not recurring, it's a 2, 1, 1, 0, 0, again 1, 1, 2, 2, 0, 0, etc. going. Therefore, this is also an irrational number. Now we are going to learn theorem 1.6. That is, let P be a prime number, and if P divides a square, means A is a positive integer. If P divides a square, then P divides A also. That is the theorem number 1.6. Let P be a prime number. That prime number divides a positive square of a positive integer, then it divides that positive integer also. Once again I will written, let P be a prime number. If P divides a square means what? It's a square of a positive integer, then P divides A also. Okay, I will explain example 7. Show that root 2 is irrational. Then first let us assume that root 2 is a rational. We are taking its contradiction. That means we have to show that what root 2 is irrational. Therefore, the contradiction we are taking, contradiction means reverse we are taking. Let us assume that root 2 is a rational number. Then if root 2 is a rational number, there exist two numbers, what R and S, such that S not equal to 0, such that root 2 is equal to R by S. Rational numbers we can express in the form of P by Q. Instead of P by Q, we took two numbers, two integers, R and S not equal to 0. Therefore, we can write root 2 as R by S. Root 2 is equal to R by S and S not equal to 0. Why we wrote R and S? Because we are assuming that what root 2 is a rational number. A rational number can be expressed in the form of P by 2. Therefore, we are taking R and S not equal to 0. Instead of P and Q, we took R and S not equal to 0. Then, if R and S have a common factor other than 1, if R and S having a common factor means what we have to do? We are cutting and dividing it by its HCF, highest common factor. If R and S have a common factor other than 1, then we divide R and S by their highest common factor to get root 2 is equal to A by B. In example I will tell, if we got root 2 is equal to 14 by 16, means we are cutting highest common factor what coming 2, 7 and 8 then 7 by 8. Same like that, here highest common factor what came? 2k. Means 2k. Same like that, we are assuming that there exists, they have a common factor. R and S having a common factor. Therefore, we are dividing it by their HCF to get root 2 is equal to A by B. Then dividing by its common factor, we are getting A and B. Here R and S good. R and S we assume that it is a irrational number. Then we are dividing it by its common factor. Then what we are getting? root 2 is equal to A by B, where A and B are co-primes. Co-primes means what? They don't have any common factor. A co-primes. So B root 2 cross multiply. B root 2 is equal to A. Understood that, Smith? First we wrote what? Root 2 is a rational number, assuming that root 2 is a rational number. Therefore, we wrote it in terms of R and S need not equal to 0. If R and S have a common factor, then we have to divide it by their HCF. Then cutting after or dividing after, what we are getting? Root 2 is equal to A by B. Then we are cross multiplying them, and A and B have no common factor. They are co-primes. Then so B root 2 is equal to A. Then squaring on both sides. Root 2 square 2 B square and A square A square. Therefore 2 divides A square. It's 2B square is equal to A square, means we can divide by 2. Then it is divisible by theorem 1.6. Since 2 divides A square, it also divides A also. What told in theorem 1? If P divides A square, then P divides A also. Same like that only here also. If 2 divides A square, 2 divides A also. So we can write A is equal to 2C. Another integer we are taking. A is equal to 2C for some integer C. On squaring, we get A square is equal to 2C whole square. Or substituting for A square, we get 2B. Already we studied that A square is equal to 2B square. Already we proved that. Therefore, substituting A square, we get 2B square is equal to 2C whole square. Or, so that 2B square is equal to 2 square 4 C square. That is, B square is equal to 2C square. Then common factor 2 and 4 cutting here 2 we will get. Therefore, B square is equal to 2C square. Then this means that 2 divides B square. So 2 divides B also. According to our theorem, if 2 divides B square, it will divide B also. Then so 2 divides B also. Both A and B. Then therefore, what we can understand that if A square is equal to 2B square, therefore both A and B have a common factor 2 as a common factor. But what is our assumption? A and B don't have any common factor. This contradicts our fact that A and B are co-primes. A and B are co-primes. We told that first we told that A and B don't have a common factor. That is, they are common, the co-primes. But now we proved that what A and B have a common factor what? 2. 2 is a common factor for A and B. This contradiction arises our assumption that root 2 is rational. What we assumed that our assumption is what? Root 2 is rational. Then A and B both have a common factor 2 means we cannot tell that root 2 is a rational number. Therefore, our assumption is false. So we can conclude that root 2 is a irrational number. Root 2 is an irrational number. We will start exercise 1.4. First problem. Prove that the following are irrational numbers. Then first problem, 1 by root 2. Then what we have to solution? 1 by root 2. On the contrary, means on the opposite we are telling us, assume that 1 by root 2 is a rational number. We have to prove what 1 by root 2 is an irrational. Therefore, its contradiction we are assuming that 1 by root 2 is an irrational number. Then 1 by root 2 is of the form P by Q, where Q and P and Q are integers. Then 1 by root 2 is equal to P by Q, and P and Q are not equal to 0. That is definition for rational numbers. Which implies that reverse doing. That is, root 2 by 1 is equal to Q by P. Then already we find out that root 2 is a rational number and it is the contradiction. Already before first example we told that root 2 is an irrational number. Then here what we are taking, root 2 by 1 is equal to Q by P. Then root 2 is an irrational number. Already we know that. That is, root 2 is a rational number and it is a contradiction. What we are telling here, we are seeing means what root 2 is a rational number, but it is a contradiction. This contradiction arises due to our assumption that 1 by root 2 is a rational number. 1 by root 2 is a rational number is a contradiction, because what is the reason? Root 2 is a irrational number. Therefore, hence we can tell that 1 by root 2 is an irrational number. And question, prove that root 3 plus root 5 is an irrational number. Then we are assuming the contradiction that, on the contrary, assume that root 3 plus root 5 is a rational number. Let root 3 plus root 5 is equal to p by q and q not equal to 0. This is the definition of rational numbers. Then squaring on both sides, what we will get? Root 3 plus root 5 whole square is equal to p square by q square. Both sides, here square coming, here p square by q square. Then that is such that this one a plus b whole square, a plus b whole square, what we are getting? A plus b whole square is equal to a square plus 2ab plus b square. That formula we are using here. Then what we will get? First one, a is equal to root 3 and b is equal to root 5. Then a square means root 3 the whole square plus 2 into root 3 into root 5 plus root 5 whole square is equal to p square by q square. Then root 3 square, what we will get? 3 getting. Root 5 square, 5 getting. And 2 into root 3 into root 5, 2 root 15. Understood? Root 3 square 3, root 5 square 5, and 2 into root 3 into root 50. Root 3 into root 5 is equal to 2 root 50. Is equal to p square by q square. Then 3 plus 5, 8. 8 plus 2 root 15 is equal to p square by q square. Then 2 root 15 is equal to this 8 we are taking to the right side. P square by q square minus 8. Which implies that 2 root 15 is equal to p square minus 2 into 8 minus 8 q square by q square. Implies that root 15 is equal to, here 2 also we are taking to the denominator. Root 15 is equal to p square minus 8q square by 2q square. That is, p and q being integers, p square minus 8q square by 2 square is a rational number. That is, p and q being integers, then p square minus 8q square by 2q square is a rational number. This lets that, what we told, root 15. Root 15 is a rational number. But we already know that root 15 is an irrational number. Then this contradicts the fact that root 15 is an irrational number. Therefore, our assumption is wrong. That is, root 3 plus root 5 is a rational number. And assumption is wrong. What is our assumption? Root 3 plus root 5 is a rational number. Therefore, we can write that root 3 plus root 5 is an irrational number. Once again, I will explain. What we have to prove? Root 3 plus root 5 is an irrational number. Then we are taking the contradiction that root 3 plus root 5 is a rational number. The rational number definition we are writing. Root 3 plus root 5 is equal to p by q and q not equal to 0. Then what we have to do? Squaring on both sides. Then root 3 plus root 5 whole square is equal to p square by q square. That is, root 3 square plus 2 into root 3 into root 5 into root 5 whole square. What formula we are using? A plus b whole square is equal to a square plus 2ab plus b square. Here a is equal to root 3, b is equal to root 5. Then a square means what coming? Root 3 whole square plus 2 into root 3 into root 5 plus root 5 whole square. Then it is equal to root 3 square 3 and root 5 square 5 and 2 into root 3 into root 5. 3 5s are 15. Then root 15 is equal to p square by q square. Then 3 plus 5, what we are getting? 8. 8 plus 2 root 15 is equal to p square by q square. Then 8 we are taking to the right side. Then what we are getting? 2 root 15 is equal to p square by q square minus 8. Then which implies that 2 root 15 is equal to 8 multiplied with q. We are converting it into improper fraction. Then p square minus 8q square by q square. 2 root 15 is equal to p square minus 8q square by q square. Then root 15, this 2 also we are taking to the denominator. Then root 15 is equal to p square minus 8q square by 2q square. Root 15 value we got. Then p and q are being integers. P square minus 8q square by 2 square is a rational number. Then p square by, what is the value of p square minus 8q square by 2 square? Root 15. Then it should be a rational number. But already we know that root 15 is a irrational number. Therefore, what we assumed that our assumption is wrong. That is, root 15 is an irrational number. Therefore, our assumption is wrong. Root 3 plus root 5 is a rational number. What we assumed that it is wrong. Therefore, we can tell that root 3 plus root 15 is an irrational number. For remaining problems, you have to do yourself. I will go to the next topic, exponential and logarithms. Then already 2 to the power x is equal to 4. Then we can directly understand that 2 square is equal to 4. Then we are getting the value x is equal to 2. Similarly, 3 to the power y is equal to 81 is equal to 3 to the power 4. 3 into 3 into 3 into 3 is equal to 81. Therefore, 3 to the power 4, it gives us y is equal to 4. But in these cases, like these cases, 2 to the power x is equal to 5 and 3 to the power x is equal to 7, we cannot understand what is the value. Or 10 to the power x is equal to 5, we are introducing another relation, that is logarithm. Logarithm we are introducing like these cases. 2 to the power x is equal to 5, 3 to the power x is equal to 7, 10 to the power x is equal to 5. These values we cannot understand directly. In these cases, we are introducing the logarithm relation. That is, 2 to the power x is equal to 5. X is a log of 5 to the base n. This power we are taking as, that one is equal to a log of 5 to the power 5 to the base 2. Similarly, that if we are writing it as x is equal to log 5 to the base 2. X is equal to log after this number 1 to write. X is equal to log 5, same base we are writing, to the power 2. Similarly, here also, in this case, x is equal to log 7 to the base 3. X is equal to log 7 to the base 3. That means, in generally, we can tell that if a and n are positive real numbers such that a not equal to 1, we define that log n to the base a is equal to x. That is, its exponential form what getting a to the power x is equal to n. Reverse we are writing here, log n to the base a is equal to x. Examples I will tell you, then you can understand more. How we can convert logarithmic form and exponential form, I will tell. Then here I give, first they are given 100 is equal to 10 square. This is the exponential form. Then we have to convert into logarithmic form means, first we have to keep the power here. 2 is equal to log, again this number 1 to write, 100 to the base 10. Next one, 81 is equal to 3 to the power 4. Then 4 1 to write first. 4 is equal to log 81 to the base 3. Base is same only coming. Power we have to write in this place and then the number we have to write log 81. The next one you say 1 by 257 is equal to 4 to the power a. Then first one to write a is equal to log 1 by 57 to the base 4. Next, how to write logarithmic form into exponential form. Then solution. First one is log 25 to the base 5 is equal to 2. Solution what we have to write? The number we have to write first. 25 is equal to 5 square. This number we have to write here. Next, x is equal to log 2 to the power log 9 to the base 2. X is equal to log 9 to the base 2. The solution what coming? This number 1 to write first. 9 is equal to 2 to the power x. The power 1 to come same. Then log 2 to the 2 to the base 2 is equal to 1. Solution what coming? 2 is equal to log 2 to the power 1. Understood how to convert? Then we will explain on the next class.